as an engineer, I don't know about you, but every time that I am building an application, I make sure that the application works really well. Be it a website, mobile application, or a desktop application, I want the application to work fast and for the user experience to be really good. That is why I always focus on the interaction between the user and the device. So every time I try and optimize my applications so that it feels very fast. A couple of days ago, when I was building a side project, I noticed that on some pages, especially on mobile devices, the application or the website was really slow and it was not a good experience at all. So I worked on how I can solve it. In this video, I'm going to tell you how I worked and solved that problem. But first, let me tell you about the project first. The project is a fairly simple application. It is a ticket reservation system for weddings, meaning that users can come onto the platform and reserve seats so that they will know where they are going to specifically sit when they come at the wedding. It's a fairly simple application, and I got a huge inspiration from Ticketmaster. Before I show you the problem, right, and how I solved it, I want to just tell you about some similarities I found between AI coding and how we did coding at first. You see, at first, we used tools like Stack Overflow. Most of the times, we copied and pasted code, but we made sure that we understood or we understand what we are copying and we are pasting. But in this AI world, I am seeing more and more developers churn out AI slop. Why? Because they are lazy to read the code that the AI gives to them and understand it, and ask questions about the code that the AI gave them. So this is my humble plea to you. Please, if you're a software engineer, don't accept anything that the AI just gives you. Make it part of your routine to fact check everything that the AI gives you, and also read and understand everything that the AI gives you before you copy and you paste code. These AI tools, they are just glorified web search engines, and they make researching for stuff really fast. So please, don't be lazy, okay? Do it the right way, and you move fast, but also save your code from crashes in the near future. Now, let's get back to what we were saying. So, on the reserve page, you go there and you reserve a seat as a user. But here's the case where sometimes when users are scrolling around, we used canvas, HTML canvas to build the seats. When users are scrolling around the mobile device, it was really slow as hell. So I did some digging and I found out that basically the framework that I was using, Canvas, right, was drawing these shapes on an HTML canvas, as I said earlier. And every time I moved around, it was trying to redraw the shapes every time. So if the mobile device is running at 60 FPS and I have 300 seats, it means that for every second, we are going to be calculating the shapes, the position, and everything about the shapes 60 times. And remember, we have 300 seats. The seats are just circles, right? So we have 300 circles denoted as seats. So when you move around the screen, when your phone is running at 60 frames per second, right, it will calculate each circle one by one, 300 times 60 times a second. This means that basically, moving around on the screen alone, if your phone or your mobile device is running 60 FPS, right, we are doing 18,000 computations for the circle every second. And this was really hurting me. What if I have 5,000 chairs? What if I have 10,000 seats? It means that I'll be calculating the 10,000 seats per the 60 frames per second, right? And this also means that basically, when performance dropped, right, like say 5 FPS per second, it will be slow as hell because you are going to calculate 5,000 seats 5 times a second. So I found a way. What did I do? Well, it's quite simple, right? There is a method in Konva.js. That method is called the cache method. What it basically does is that if you have a layer of shapes, right, take that layer and create an image of that layer and store it somewhere. Now, every time you move around, in my case, every time I move the seats around, I did not need to compute the position and the vector shapes of all these 300 shapes, but rather move the image around smoothly. That's all. That's what a simple fix that I did. You see, when we say cache, right, we are talking about storing items for future use. And that's exactly what Konva.js just did. It grabbed the image of the shapes and moved the image around instead of recalculating the shapes 60 times per second while I moved around. But there came another issue. You see, we are moving an image that we captured around, right? What if a user clicks on a seat? What will we do? Well, that's a good question. Well, we did something relatively simple. Remember, I told you that the seats were in sections, right? And we are caching individual sections. So what we did was that when the user clicked on a seat, we call an uncache method on that specific section, and this will re-render or calculate the circles inside that section. And this time, it will not be saved as a bitmap image, but rather actual shapes on the canvas. After that, we applied the necessary color corrections to make sure the user know that their interaction was recorded and has been computed. For that, we just recache the whole section again, and this happens in a split second, so it's really fast and you don't even see it happening. The moment you click, we recalculate it, we add everything that we need to add to that vector image, and we recache it. Caching is a fundamental aspect in computer science, and if you are an upcoming software engineer, I really tell you that you need to dive more into caching so that you are going to learn more about caching. It is not used only over here. Caching is also used mainly in API designs. There are so many things that this project is teaching me, and I would like to share them with you. But here's the case, I feel like I am running out of time in this video. So you know something, if you want to learn more about things like using Pythagoras theorem to calculate the distance between two fingers, or using the request animation frame method in JavaScript to create a smooth game across all devices, no matter their refresh rate, please make sure to subscribe. There are also more issues to fix. One example is that when a user selects a seat, I am using arrow.filter to filter through the whole seats and know the particular seat that the user clicked using the ID. Now, that is really problematic. Why? Because let's say you have 5,000 seats. The user click on the last seat, which will be index 499. In index 499, right, running arrow.filter on the whole seats array will take O of n, meaning it will take 4,999 iterations to just get that one seat and do any computation that I want to do on that seat. But here's the case that I know I can reduce that algorithm complexity from O of n to something smaller. So please, if you want to see me suffer writing that algorithm, I'd like to see you in the next video. So make sure to subscribe. If this video too was fun and you enjoyed watching this video, please don't forget to leave a thumbs up on this video. I'll see you guys in the next one. And always remember, we are doing this for the fun of it. Don't just accept anything that the AI gives you. Make it your plan. Please, if you